If I'm using the distributive property shows how to expand out or how to multiply polynomials. When I multiply 2 times x plus 1, we already showed in example 1 that this is going to equal 2x plus 2. That x times x plus 3 is going to give me x squared plus 3x. 2x times x minus 2 is going to be 2x squared minus 4x. Negative 3 times x minus 1 gives me negative 3x plus 3. And x minus 1 times 2x gives me 2x squared minus 2x. These are all examples of a distributive property. If I take a times b plus c, then it would be the same as if I multiplied a times b and a times c. Doesn't matter if I do it in the other direction. If I have b plus c times a, then it's going to be b times a and c times a. So if I'm using the distributive property to solve what these products are, I'm going to say that this is going to be equivalent to 4 times 3x plus 4 times 1. This would be the same as 12x plus 4. If I do the same thing for b, I'm going to take that negative 5 and multiply it by all 3 of the terms here. Negative 5 times 2x squared is going to be negative 10x squareds. Negative 5 times x is negative 5x, and negative 5 and negative 6 makes positive 30. If I have x to the 3 minus 2 times x squared, same idea once again. I'm going to take that x to the 3 multiplied by x squared and that negative 2 times x squared. X to the 3 and x squared are going to give me x to the 5. And negative 2 times x squared is negative 2x squareds. When we get to the last one, negative 3x times 7x, well, negative 3 times 7 is negative 21. And x makes x squared. Negative 3 and negative 2 makes positive 6, and x times y is just xy. And negative 3x and z makes negative 3x z. In the process we just did, we expanded the polynomial expressions using the distributive property, remembering that I'm using the distributive property to say that a coefficient is going to get multiplied into all the terms that exist inside of the brackets, and the exponent rule that if I have the same base multiplied by 2 different powers, I'm going to take the sum of what those exponents are. If that is true, then the first thing I'm going to do is I'm going to expand this out. So because the 6 isn't getting multiplied by anything, I'm just going to leave that as 6. But I need to multiply the negative 4, which is the coefficient, into both parts here. So I'm going to have negative 32x and negative 4. When it says simplify, I'm going to combine my like terms. Here, 6 and negative 4 being my like terms. And I'm going to say that this is negative 32x plus 2. In the second case, I'm going to take the 4 and expand it out into both parts. And I'm going to take the negative 2 and expand it out into both parts. So this is going to give me 8x minus 12 minus 2x plus 12. When I combine the like terms, the funny thing is I can see right away that the negative 12 and the positive 12 are going to cancel each other out. I can still combine the 8x and the negative 2x, and I'm just left with 6x's. Example C, exact same process. Take the 5x and multiply it into all three parts. Take that negative, or negative 1, and expand it into both parts, which just means that what's inside of the brackets, the sign is going to flip. So this is going to give me 15x to the 3 minus 35x squareds plus 5x. When I apply the negative, I get negative 4x and negative 3x squared. I only have one x to the 3, so that's not going to have a like term. I have 2x squareds I can combine. And I have 2 x's that I can combine. So this is going to leave me with 15x to the 3, negative 35x squared and negative 3x squared gives me negative 38x squareds, and 5x and negative 4x leaves me with just 1x. If I'm asked to determine a simplified expression for the area of a given shape, well, I'm going to consider this by, in this case, adding the two triangles together, rectangles. So I'm going to draw a line that splits us up into two separate rectangles. I know one of them has the dimensions of 2x and 3x plus 2. The other one has one side length of x plus 5, and the other side length in here is going to be the difference between this side length and this side length. If the whole big side length is 4x's and this smaller one is 2x, then what it's missing down here is another 2x. Based on that, now I can say that this would be the top rectangle, 2x times 3x plus 2, combined with the bottom rectangle, 2x and x plus 5. And then we're just going to do the same process we did up on the top. We're going to expand it out. 2x and 3x gives me 6x squareds. 2x and 2 gives me 4x's. 2x and x gives me 2x squareds, and 2x and 5 gives me 10x's. When I combine these, I get 8x squareds and 14x's. Now, the other way I could have done this is I could have subtracted the area of two rectangles. I could have taken the area of the bigger rectangle and then taken off the area of the smaller rectangle. Now, in order to do this, I would still need to know what the dimensions of this smaller rectangle are. Well, we already know what one of them is. We know that that side length is 2x. We can use the same trick that we did to solve that side length to solve for what the side length on the top here would be. It's going to be this whole side length take away this side length. Well, if I have 3 x's and I took away an x, then I'm left with 2 x's. If I have 2 and I took away 5, then I'm left with negative 3. Now I can say that this is going to be the bigger rectangle minus a smaller rectangle. And the area that's left over should be the same. I have 12x squared plus 8x minus 4x squared plus 6x. Be careful of those double negatives. And this is going to leave me with 8x squared plus 14x's. Doesn't matter if I combine two small rectangles or I take the bigger rectangle and subtract the missing area. If I did it properly, my results are the same. All right, go ahead, do some practice.